with us, 500 people registered for today. Maybe because of you and your insight into the practicality of adding large and storage combined, as we all understand that we use one of the frontiers in that field.
घंटों को पैसा आना तो ज्यादा ना
Welcome to the webinar. You have entered as an attendee in listen-only mode. Joint secretaries and secretaries and MNIE, Abhishek, what do you reply when you hear like this? I have heard similar cases in Germany now for 30 years, and discoms are doing very well. Despite the fact that we are adding 25 storage systems per year, and also some cases for large transmission storage. Some cases are coming, not too many. But most of the storage cases we see here, so it's a booming business, come from the residential sector because our electricity is more expensive in the residential sector than for commercial. So, do you see a threat of storage? Especially distributed storage coming at you as it used to be the argument for many years ago. Is it a threat to a discom? When you hear a joint secretary saying sooner or later everybody will have PV and storage, and we don't need an electricity bill from the discom showing us how many units we need to cool our houses down. Thank you, Jörg. So yeah, I have heard this from secretaries and joint secretaries also. So they want to say, and they say that they want freedom from the discount. So I'm waiting for the day when I have the complete freedom from the discount. Okay. So the point what we are or they are talking about is the idea of virtual power plant, wherein everybody is self-sufficient. But then, as per my best of the knowledge and whatever conversations I had with my peers in Europe or United States, the grid is going to remain here. So there has to be something called grid operation. So the business model of the current discom might, transition. You can have a separate model for the discom, which can, transform to a DSO, distribution system operator. So in fact, maybe the model changes, and therefore you should also change. What I'm saying is, this is not a threat. Maybe you are adamant for current way to be the way to do the business. Then it might be a threat. Having said that, what is the current model? The current model represents the rate of return asset-based. So we are okay if the retail tariff is designed in such a way that we are able to recover the fixed cost of our business. What is our fixed cost of business? Fixed cost of the business, 80% increase of daily is power purchase cost. So that power purchase cost, and we have set fixed cost PPA. Fixed cost has to be given. And 40% of my power purchase cost, if I am not using plant, I have to pay. Challenge is there. Suppose I'll give an example. Today, Darjeeling State has completed 25 years. It's going to complete on 30th of this month. What is the fixed cost burden? 500 crores per annum on Delhi. Okay. Now, we are not scheduling this plant for the last, say, 10 months or 11 months because of multiple reasons. But then I have to pay 500 crores. That is the burden on me. So if such kind of, burden are removed, so what all fixed costs I am left with that 20%, that 20% is nothing but my cost to serve. Cost to serve is transmission, my own overheads, salaries, O&M expenses, etc. Now, that is insecure. And therefore, if these consumers go away and go to meet their own self-sufficiency, they are still connected to the grid. They are paying some charge, which is called grid connect charges. For example, you might have heard in the case of India's. They have introduced grid connect charges for the solar PV, but it has been deferred for the next 2 years because the solarization has not been done. So that model will come. So the idea is I am getting my cost plus return. My fixed cost is being met. I'm okay, and I'm getting a regulated return on my business. So that way I'm okay. So here you are getting power from grid, or you are getting power from solar PV. So, and the last point which I want to make, 100% consumer base cannot be 100% self-reliant, and they will need the support of the grid. Everybody will not have the room or the model to save subsequently and sufficient. I take a pause.
Thank you. Thank you very much. A question to Dr. Tulster, maybe a provoking question after your bold statement. We have many use cases for storage in India, but no business case. Have you taken into account, this question comes in here, all the maintenance costs of ETs in India under Indian conditions? The way I read this question is as such that India is facing very high temperatures and the grid in India needs to be cooled. Most of these ETs, and I don't know how many Abhishek Ranjan has on this grid. I understand once a number at least 6,000 or so. But many of them, many large ones, need cooling. It's almost like replacing a combustion engine car with an electric car. When you come in with electrical storage to help to prolong the lifetime of ETs. Have you taken all these things into account, or did you just use generic assumptions from like grid distribution grid in Germany?
Of course, we have taken quite a lot of information from India. Maybe to mention also Terry being involved. Thank you very much also for your support. Who have been doing some investigations also on in the Indian case to support us. In general, the business case was so far away that even if we consider this, we just have to say that batteries today are still so expensive compared to the transformers that it just is, even if we have not considered this, it would make the situation much better. And I would be careful with comparing combustion engines with electric vehicles and say, okay, that one is a transformer and the other one is the battery. I believe the battery itself is a bit more complex even actually than the transformer, and both are electric. So from this perspective, I think that it's still today it's actually the better choice to upgrade a transformer in many cases. Not always. There are as I said, use cases, and also mentioned that in certain cases, especially if you want to be fast, for example, it could be good to just put a battery on wheels, for example, to your transformer in order to reduce the loading situation. But on the long run, and that's what we looked into, on the long run, like in a mass situation, we don't see that batteries will replace transformers on the long run. So certain cases, there will be definitely also situations and business cases where it makes sense to have a battery then placed there.
Okay. Yeah, the question was, the way I understand it, was more related to the maintenance costs, so cooling with oil or cooling with water, keeping this up because you need to circulate the oil through the rigs of the ETs and things like this. So, but
also batteries need to be cooled.
Batteries need to be cooled as well, you're right, or they can be placed somewhere else and further away, and they're much smaller in footprint than a DC station. So, but we could argue that. Yeah, we could argue that, and maybe we will see once Abhishek Anja and his team are done placing these 1,000 kilowatt hours or 1 megawatt hour of sample storage into the field, and maybe we can contact a firm like you and do the evaluation properly and see what the actual conditions are we operate on.
It's very, very interesting to see that, yes.
Yeah. Mr. Raola, you're the only one who comes from the private sector. We are all restricted to public diplomacy here, so I can only ask you that question. There is a trade war between China and India, which provoked the Indian government to proclaim the self-reliance roadmap. I cannot pronounce the Indian proper phrase properly.
Sure.
But it's self-reliance, meaning made in India or buy in India or procure in India. So it is a big push, supported also by the German government, because we like to see many German companies investing in India. You are aware of this push. We have been in these discussions together with us many times. So when it comes to storage, when it comes to cells, where is India in regards to domestic content? Or do you face already problems in procuring and bringing in batteries made in Korea, made in China? It's almost the case all over the world, maybe except for Germany, where Tesla has invested into the largest battery factory. But yeah, what is your situation and when you get business to sustain that under the current conditions? Yeah. So probably you only have several hundred people listening, so you can be very
as candid as possible.
So yeah, I mean, I'll probably take a step back, and what Sebastian just talked about from the commercial standpoint, which is something which is really important from an Indian standpoint as well. There are so many people. I mean, especially if I talk from a perspective of the large consumers, and these are the consumers who are most important for the distribution companies as well. The contribution margin from these consumers are the highest as compared to the other sets of consumers, such as residential. And from an Indian standpoint, if you'll see, I mean, these are the ones who are cross-subsidizing the residential consumers. These high-paying consumers are very, very keen to kind of evaluate these kind of opportunities, especially the energy storage. And this has increased a lot, especially. I mean, at least the discussions have increased a lot in last months because of the several reasons. One of them, obviously, is a regulatory challenge which we face out here in India, because the amount of electricity that you can buy from a private player who can access model and things have been constrained. Therefore, those discussions have increased a lot in near term. What I have seen, I mean, to answer your question, what I have seen here is people are, but they are very, very skeptical about the amount of money that they will have to shell out in case they want to shift to a storage. So therefore, all those discussions have happened, but I don't see many of them fructifying in the near term because of the reason that we just discussed, and I kind of agree with Professor Oscar when he says that we are still some time away from that being very, very
commercially viable at a large scale with some subsidies and all, and with government support. I'm sure that we should be there, but I think from a private sector standpoint, from the commercial and industry consumer standpoint, I think we're still a little far off. But there are large. There are many business case or use cases that we can probably look at. One of them, of course, is the diesel abatement. That is where batteries definitely make sort of sense. Still, as compared to the other alternate source of power being the grid itself, the grid is being used as a source in this case. So that is where it is still making sense. Having said that, people are still skeptical because of the large scale adoption still has not happened, and they want to be very sure before they want to embark upon that. And said that we are evaluating this business line very, very seriously. And this we believe is definitely something that will become important in the coming time. But from a sourcing perspective, short answer to that, we still are facing those challenges in terms of securing or sourcing batteries and understanding the details of it, the chemistry behind it. So that's something that's still facing a challenge. But I believe that probably near term we should be able to that. Yeah, I would continue a little bit with a question in regards to distributed storage. Distributed storage. When I came to India 5 years ago, I was shocked that I have to have a battery in front of my house, in front of my apartment. You call it UPS system, uninterrupted power supply. You mentioned diesel gensets. So we did some research then into the sector. We understand that as of today, not maybe in Delhi, not maybe in Mumbai, but as of today, roughly 9 billion UPS systems are being sold every year, which means they give you backup power, which is the capacity which sits there and not utilized, but they give you backup power when needed. Sometimes as much as a full night of power, 11 hours, sometimes less than a few minutes when you only have short power interruptions. It also requires, which is completely unique for the world, and I had a master's thesis written on that by one of my interns, because it was so fascinating. It also requires two wiring systems in the house, one for critical load and one for the normal load or normal loads. And I also started then together with my team this PV port project, which is a combination of battery and storage, thinking that we could utilize these UPS systems on a more frequent basis, not just when the power is away, because every household has one or could have one, and the ones in the household could actively participate in the grid, like from Abhishek Ranjan. And if we would have access to it through a circuit board and turn them on and off, could do demand side management. So we are running now a field test in two states, in Delhi and in Gujarat, not with many systems, 40 systems, to see if this is possible, if households respond to that. And what we see is that households shift indeed from I'm buying every 2 years and that asset combination for my UPS because I still have to have UPS, and I'm buying once every 10 years lithium-ion battery. Do you see that as well for you on the residential level, or is this something where you stay out of it? So, as a business plan, we are still a little far off from a residential perspective because the kind of bandwidth that will be required will be huge, and that will put a lot of strain. So that's where, at least from a C&I perspective, which are the larger consumers, is something that we are focusing on right now. But I think depending upon how this pans out, we'll be happy to evaluate that sector as well. But as of now, I think we will probably start with the commercial and industry consumers. Understood. Makes sense. Then back to Dr. Tröster with the question to you, someone who was dealing with India now for how many years? 5 years, 6 years, on a regular basis. from Madhya Pradesh to the state of Delhi, you have been involved. There's a question. Most of the I'm reading it. Most of the rooftop PV system owners are complaining in India about the lesser solar power generation per year per annum as compared to feasibility figures. So I'm not referring to any of your reports. That's why rooftop solar is not gaining momentum in India as expected. What could be the serious reason, and is it similar in Germany?
So that sounds a bit like degradation. If I got this right, to say, okay, like from year to year with this very same PV system, I'm gaining or I'm harvesting less energy. Did I get that right?
Yes or no? I think it is also the assumption we all have. India is a sun-rich country with 2,000 watts per square meter of potential, and we should have at least 1,500 kilowatt hours per kilowatt capacity installed. You see, not even 1,000, and we try to understand why. Maybe it's a combination of things, and maybe it has heavily to do with soiling. So we have dust coming from Africa into India on a regular basis, and then we put normal pollution, which also adds to that. So layers of dust that you don't clean within days. Any opinion from you on Germany or from the rest of the world you operate in? How is this topic of maintaining O&M of solar? Is this something you can add some comments to that?
I think maintenance is much more important in India than compared to Germany, I would say. But I think it's two things. A, it is about the projection of how much you can actually harvest, which is quite important to consider, like dust and heat and so on in India, much more than in Germany, because the efficiency of the systems will reduce with higher temperatures. And therefore, it cannot really expect as like having a clear sky, optimal conditions, and then doing the calculations from that. So if this is the case, then I can only recommend to be serious on the calculations, consider them, include them in your calculation, into your business cases. If you are doing calculations on the expected harvesting of solar, and then work with that. It will be still like 50%, 60% higher compared to Germany. And I mentioned yesterday also the characteristic is much more interesting over the year because it stays fairly flat. Yeah, so it's really there every day. Also the peaks, we have actually higher peaks in Germany during the summer than you have because we don't have the dust. It's not as hot and so on. Yeah, so we have more during the summer compared to you, but much less during the winter time. And this is from a power system perspective very, very interesting to have this there. On the other hand, of course, it's also a question of quality. And I think that's always a problem or an issue in India for sure. That's what I've learned. That like degradation of PV systems. So from year to year, the harvesting is reduced. Maybe also inverter is reducing in its power. But it's mainly it's the PV panels that the quality might not be sufficient there, which has been used, because definitely that's a topic which certain technologies do have more than others. And as far as I know, there are also techniques, especially which typically are used more larger plants, that you can actually reverse it, so to improve the efficiency again from modules, but that shouldn't be done too late. So this technique and typically it doesn't have works to do. That's that topic before Mr. Corona and Mr. Becker for a second. Let me see if I can rephrase the question a bit better here. Now we talked about inverters at the beginning. We talked about hybrid inverters. We talked about inverters which can so
these hard conditions seen by or seen by the Indian grids in power quality. Number one, so the number one question here is is the inverters sector in India indigenous? So for you, power pure inverters which are made in India, is there a source for that? Or do you rely on cost effective, because otherwise we cannot meet the cost expectations? Question for you and question for Dr. Tröster. Can you explain to these 200 people here in the audience the 52 hertz problem? The reason why I'm posting that is we got a call from Gujarat. Gujarat has 5 discounts. Gujarat is adding every 6 months 500 megawatts of rooftop solar antennas onto the grid. Several 100,000 systems are coming. Several 100,000 inverters are coming, and they are very concerned about the grid and the parameters of the grid. So the voltage or the frequency actually shifting away. Can you explain after the answer from the inverters whether or not there are indigenous inverters available, or which ones do you buy? Are you concerned of the quality of these hybrid inverters? And can you explain to us the danger of the so-called 52 hertz problem? Mr. Howell, you first. Thank you. Sure. Thanks for that. I think at Renew Power, for us, quality is definitely paramount. When we are constructing the projects, we are looking the project to perform for 25 years or 20 years, whatever that might be, or 15 years, whatever that might be. Even from a rooftop perspective, when we are engaging with our consumers and customers, it's very important for us to there shouldn't be over promise and under delivery, and this is something which is something which Professor Dr. Tröster also talked about. He also mentioned the quality thing, and this is something what actually happens many a times. But I mean that on that note, I mean from a perspective of Renew Power, we are. Sorry, there's some question. Yeah, that was Chowdhury sir that joined from AMT Energy. Okay, welcome. Yeah, please continue. Sure. So essentially, from a that's why from a quality perspective, we are not that fixated that we will be buying it only from India. We are procuring from outside India as well. Having said that, if there are inverters, modules, or whatsoever, if they are crossing our quality checks and balances, we are open to buy it from anywhere. And of course, I mean, if we have a level playing field, or if we have two people or two suppliers probably at a similar footing, we might go with made in India thing. So that's where we are. I mean, we are pushing for that GIZ to fund make in India inverter below 40,000 rupees. So we're working on that. We're working on some partners in Germany, Carco, SMA, Costal, to join forces with Indian brands, and then we need to come up with something that seems to be the key to these hybrid inverters seem to be the key to eliminating UPS systems. If they stay on under a limited power supply, and if a battery is not needed, I think we have a very strong case for good, strong, stable hybrid inverters. We currently don't find it. So thanks for being so diplomatic in this critical question. Now the 52 hertz problem for Dr. Tröster, if you can explain it to us, layman terms, and to scare a little bit Abhishek Ranjan as a discom operator, what he may face if he continues adding inverters without reactive power control.
Nothing to fear. Nothing to fear. First of all, I know manufacturers who are producing, so international manufacturers producing very high quality products in India. So it is possible, from this perspective. But now, talking about the 50.2 hertz problem, so it's about 200 millihertz above 50. And it is not really a quality issue, it's more a grid code issue, so to say. The very first grid codes, which was replaced in Germany, they were actually requesting from PV inverters to switch off if the frequency goes above 50.2 hertz, so 200 millihertz out of sync, basically, because they consider this is an abnormal condition and we don't want to have anybody to interfere, especially not photovoltaic, which will never have any high share in Germany anyways. There will be only a few, and if they are, it's above 50.2, then please kick them out. We do our job, and then if we're back, PV can come back. That was the idea, that was the thinking behind it. And the problem is that in the meantime, then more and more and more PV came into play, and every inverter was programmed with 50.2 hertz. And suddenly we had a couple of gigawatts of PV inverters in the system, in the power system, which would be triggered by a case. It has not happened, but the fear was they would be triggered if 50.2 hertz were surpassed, that they all switch off, basically, and then even primary serve is not sufficient to cover for that. So there was a risk of a blackout of all of Europe because of this 50.2 hertz issue. And but luckily we were able to recognize this and find pretty quick solutions by reprogramming the inverters. It took quite some time, it took quite some money to do that, but it did not really happen, that it did not cause a blackout in Europe. And now coming back to the Indian situation, I think we're pretty on the safe side from a quality point of view. If we have different manufacturers of inverters there, so if there's not like the inverter, which is used primarily, because then they cannot put everywhere the same mistake in, so from a quality perspective, and we need to get the grid code right, that we don't have this triggering point. If we're talking about reactive power, okay, there might be a failure somewhere, in its distribution system, but frequency we can see more or less everywhere. Therefore, triggering frequency is really, really critical, and that needs to be taken into account.
Yeah, thank you very much, and I hope that answers this question we got in. Abhishek, is this something you already are dealing with, or are you saying we're still far away from having this capacity in our DTs?
So in this sense, if you talk about the capability of the inverter and problem, I think yes, as Vibha has said, as of now, there is no such thing in India. But in the EMS portion, the tender that we did and also that we are implementing, we are finding issues very similar to what we see in the metering arena. In the metering arena, you have multiple OEMs. We try to roll out the smart metering, so there is no interoperability. That is one of the biggest challenges of smart metering. Here also, there is no interoperability of EMS or the energy management system, so-called, which is being provided along with the ECS of the BESS. Yes. That is a big challenge. For the protocol, we would like to specify the tender documents or something, which is universally accepted also by the CEA, for example. Because here, like for example, we have vendor A who is bringing me science. I won't name anyone, but some vendor A is there, he's providing the EMS. And tomorrow in the mix, some vendor B comes. He said, no, my ECS will not be interoperable. Suddenly, you are multiple purposes in your system. You want a single distributor that needs to manage making sure you have top. I know some protocols like OpenIDR or these kind of protocols are there, but they are yet to be adopted in India context. So that is one of the challenges we anticipate, and we should not go the smart meter way. That is the challenge. Otherwise, I think we are still in infancy. We are yet to see the practical implementation of those problems.
Yeah, a good point. The standardization in the sector, well taken. Thank you. So we are a little bit beyond time and schedule already. I would return to our currently invisible panel member, Mr. Chaudhary, COO at AMP Energy. Sir, can you hear us? Are you audible to us? And do you want to add to today's topic